How's it going, guys? This is number 18 on the website, and it reads, a 15 kilogram cart is moving with a velocity of 7.25 meters a second down a level hallway. A constant force of negative 10 newtons acts on the cart, and its velocity becomes 3.20 meters a second. Assume that air resistance is negligible. So now I drew a diagram. So this is what was happening with the cart originally. It's a 15 kilogram cart moving at 7.25 meters a second, and what we'll say the right is the positive direction and the left is the negative direction. And I made the left arrow the negative direction, negative 10 newtons. And then so basically this car is moving in one direction, then something slows it down, a force of negative 10 newtons slows it down, and then it keeps on moving along at 3.20 meters a second after it's been slowed down. So that's essentially what happened in this scenario. And question A, so 18A asks, what is the change in kinetic energy of the cart? Now, there's a couple of different ways to find kinetic energy, but the equation that we're going to use here is Ke is equal to 1/2 mv squared. And just in case, I'll write you the PE equation as well. We're not going to need it for this question, but for future questions, we're definitely going to need it. As like a preview, teaser. So now we're trying to find the kinetic energy. So we're going to find the kinetic energy of this first, and then this. So kinetic energy is 1/2 mv squared, which means we just need the mass and the velocity, and we can find kinetic energy. So kinetic energy, and I'm going to write initial, was 15, 1/2 times 15 times 7.25 squared. Then Ke final equals 1/2 15 3.20 squared. So now let's do both of those. Plug it into your calculator. Now for the initial kinetic energy, you have 394.22 joules. On the bottom you have 1 divided by 2 times 15 times 3.20 squared. So you got 76.8 joules. Now what you're going to do is, we're trying to figure out how much energy, what was the energy change from here to here. So, the energy obviously went down. It went from 394 joules to 76.8 joules. So what we're going to do is, we're going to find the change, right? So we're going to do 394.22. Subtract by 76.8. So 394.22 minus 76.8. That gives me 317.42 joules. We have to remember, this is not positive 317.42. This is negative 317.42. Why? Because guess what? The joules went down. It didn't go up. It didn't gain 317. It lost 317. So we're going to put a negative in front of that. And that's the answer for part A. We circled that. That's the answer for part A. Answer for part B, how much work was done on the cart? It's the exact same number. Why? Because work is also in joules and kinetic energy is also in joules. And in this equation, in this question, kinetic energy is equal to work. Because guess what? This cart does not have any potential energy, right? It's not sitting on top of a hill or anything. We don't know where it is. We just know that it's sliding. I don't know, it's just rolling along, right? We don't know how high it is, anything like that. So that's why kinetic energy is equal to work in this question. So part B has the exact same number. For part C, how far did the cart move while the force acted? We're going to plug that into the equation. I'm going to delete all this. I'm going to plug that into the equation. Work is equal to force times distance. That one right there. So the work It's negative 317.42 joules. Equal to force, negative 10. There's a literal number there. Times distance, and we don't know what that is. Now we can just quickly solve. And our distance is 31.742 meters. And yeah, that's going to be your final answer. And that's going to be the answer for part C of number 18.